Hey, so today we're going to be going over some basic matrix operations. So we're going to be going over matrix addition, subtraction, matrix multiplication by a scalar value, and then matrix multiplication by another matrix. So let's start with matrix addition. When adding two matrices, they must be the exact same size, both in number of columns and rows. So as we can see up here, matrix A is a 3 by 3 matrix because it has 3 columns and 3 rows. And matrix B is also a 3 by 3 matrix because it also has 3 columns and 3 rows. So we can do the operation of matrix addition between these two matrices. So let's do that. Matrix A plus matrix B is, so when adding two matrices together, we look at the number in the same position in each matrix and add those two numbers together, and then put that in that position in the new matrix. For example, in matrix A here in column 1, row 1, we have a 1, and in matrix B in column 1, row 1, we have a 2. So for column 1, row 1 of our new matrix, A plus B, we would add those 1 and 2 together to get 3. Let's keep going. Matrix A in column 2, row 1 has a 2, and in column 2, row 1 of B, we have a 0, so 2 plus 0 is 2. So we'd put that in column 2, row 1 of our new matrix. So I'm going to fill out the rest of this matrix. I encourage you to pause the video and try this by yourself. Alright, here's the answer to A plus B. Hopefully you got this right. Let's move on to matrix subtraction. So for matrix subtraction, just like with addition, we're going to be operating only on the same number in the same positions in each matrix, except for instead of adding the two, we're going to subtract the second one from the first. So let's start with column 1, row 1 again. 1 minus 2 is negative 1. In column 2, row 1, 2 minus 0 is 2. And so on. So I'm going to, again, pause the video. You should pause the video, and I'm going to fill out the rest of this matrix. Alright, so hopefully you got this as your answer. So what we were doing here is, in matrix subtraction, is we weren't actually just subtracting the numbers. Instead, this is equivalent to matrix A plus negative 1 times matrix B. So what we were doing here is actually scalar multiplication. So that's what we're going to go over next. For scalar multiplication, when you have a matrix multiplied by a scalar, which is just like a number, you just multiply that scalar by each term in the matrix. So let's go over multiplying 2 by A. So our scalar is 2, and we're going to multiply that by matrix A. So all we do is, in our number in the first position here, 1 times 2 is 2. So that's going to be in the same position here. In column 2, row 1, we have 2, and so 2 times 2 is 4. So that's what we're going to have here. Alright, again, I'm going to fill out this matrix. I encourage you to pause the video and try this by yourself. Alright, here's our answer. So hopefully you got this in your practice. Alright, so now we're going to move on to, we're going to put everything together. So let's see if we can find 2 times matrix A minus 3 times matrix B. So this is, we're just putting all the concepts together. Let's start with, so let's write out our new matrix. So in column 1, row 1 of matrix A, we have a 1. And so because we have 2 of A, we're going to multiply that by 2. So we have 2 here. Column 1, row 1 of matrix B, we have a 2, and we're multiplying that by negative 3. So that's going to be minus 6. And we're going to do this for every other position. Column 2, row 1 of matrix A, we have a 2, so that's times 2 is 4. And column 1, row 2 of matrix B, or column 2, row 1 of matrix B is a 0, so that's negative 3 times 0, which is minus 0. So I'm going to, again, fill out the rest of this matrix. Try this on your own, and let's see if we can come up with the same answer here. Alright, so here's our final answer for 2A minus 3B. So hopefully you got this. As you can see, I just went through and wrote out what 2A would be and what negative 3B would be for each position, and then did the math in a second matrix. So, yep, here's the answer. And let's move on to matrix multiplication. Right, so let's multiply matrix A by matrix B. So first let's write out the size of each matrix. Matrix A has 3 rows, so it is a 3 by 2 columns, so 3 by 2. Matrix B has 2 rows and 2 columns, so it is a 2 by 2. So when determining whether matrices can be multiplied together, we have to make sure the first matrix has the same number of columns as the second matrix has rows. So matrix A has 2 columns, matrix B has 2 rows, so these two matrices can be multiplied together. If you're looking at like the size written out, you can see 2 here for columns, 2 here for rows. So because it's the same, we know we can multiply these two matrices. Alright, so when actually multiplying matrices, what you do is you take the row of the first matrix and multiply it by the column of the second matrix. And so if it's row number 1 and column number 1, then you put that in spot 1, 1 of the new matrix. So let's go more in depth so you can actually understand what I mean. So we're going to start by taking row 1 of matrix A and multiplying that by column 1 of matrix B. So we start with position 1. So right here we have our -1. Let's multiply that by -3. So we have 3 here. And then we have our 3 here, and we multiply that by -4. So we get -12. And that goes in that position. So that's row 1 by column 1. Next, let's do row 1 by column 2, which will go in 1, 2 position. So that is -1 times -2, which is -2. And 3 times 1, which is 3. Okay, so let's do row 2 by column 1, which would go in position row 2, column 1, in the new matrix. So that's 4 times -3, which is -12. -2 times -4, which is 8. And then let's do row 2 by column 2. So that would go in position 2, 2 of our new matrix. 4 times 2 is 8, and -2 times 1 is -2. Alright, so I'm going to quickly do the last two, -15, and then 10. So if we simplify this, our new matrix A times B is -9, 1, -4, 6, -15, 10. So a quick recap. The matrix A, so when multiplying two matrices, the first matrix must have the same number of columns as the second matrix has rows, but when actually multiplying the two matrices, you multiply rows of the first matrix by columns of the second matrix. Alright, so hopefully that was at least a little bit helpful, and hopefully you learned something.